All right, but so we're going to look at something called point slope form today, and we're going to look at something called standard form. And then at the end of our notes, we're going to talk about parallel and perpendicular lines, which should be a review from geometry. You most likely dealt with those, but let's get going. Let's see how these go. And as usual, if you got a question, just put something in the chat, or if you want, you can even unmute yourself. But I don't know, this class is pretty quiet from what I've seen, but I don't know. Could just be maybe you don't like the class. I don't know. But all right, so looking at point slope form, the equation of a line in point slope form is through a point x1, y1 with a slope of m. You can see this is point slope form. That's like the general form right there. This formula just comes from the slope formula. I don't know if it's really that important to work this out, but if you just multiplied this denominator across to like both sides, you would get that m times x minus x1 equals y minus y1, which if you look, it's what I put in this box here, just reversed. So this just, I mean, all this is trying to show you right here is that this formula, y minus y1 equals m times x minus x1, that just comes from the slope formula. Am I ever going to ask you that? Never, no. So it's not that important, but just understand that's where this form comes from. It's just based on the slope formula. If you remember doing proofs in geometry, we won't really be doing proofs in here, but if you wanted to prove why this formula is true, you could just derive it from the slope formula. So if you were doing like a proof, that's what you could do, but you won't really see a lot of proofs in here, if any. I don't do a lot of proofs, but you can in algebra. You can prove different things similar to how you did in geometry. You don't usually do like tables though. All right, example 1, a line passes through a point, -5, 2, and has a slope of 3/4. Write an equation for this line. So we're gonna write it in point slope form. So using what's in that box, you always have a y, and you just use your point. So like this point, this point, like that's your x1, and that's your y1. So we would just plug in our y1, so it'd be -2 equals our slope, which they gave us, 3/4 times our x minus x1. So you always keep the x, and then you plug in your x1. So since it's -5, minus -5 would turn into a +5. Or basically, when you plug it into this formula, it's always the opposite sign of what you started with. Like this is a -2, this is a +5. That makes sense. But this is point slope form. Point slope form, what it gives you or what you need to do, obviously it's in the name. All you need for point slope form, or what it does give you, it gives you a point on your line and it gives you your slope. But I mean, I think that kind of is a dead giveaway from the name. It is called point slope after all. All right, so I'll try and keep this up. But next we're gonna look at standard form. And standard form is kind of like the redheaded stepchild of the family. It's not that useful unless you need it or if it's given to you. There's not a lot of time, especially when you're graphing, there's not a lot of time where you would want to get something in standard form. The only thing I can really think of is standard form is nice if you're solving like a system of equations. If you like doing like elimination, like the elimination method to solve systems. I don't know how much you guys know about systems, but you definitely probably did it in Algebra 1. But it's nice if you can get something in standard form if you're using for like systems of equations. All right, the equation of a line in standard form is this: ax plus by equals c, where a and b and c are real numbers. A is not negative, and A and B are not both 0. I'll kind of explain. There's different, depending on where you look, the definition for standard form can be a little bit different. Some are a little more proper, like they don't want the first coefficient to be negative. Like some websites or books you might look at, they might not care. I personally don't care if I know this says A is not negative here in the notes, but for me, does it really matter? I don't think so, but I guess it depends who you ask what the definition of standard form. I've seen different definitions in different books or different places I've looked, so it's kind of up to you, but I'll kind of explain as we go through this first one what I mean by that. So we want to write the equation of this line in standard form. So basically, if you look, we have to get our x's and y's to the left side of our equation and the constants by themselves. So I guess I'll erase that. So if I want to get this in standard form, I'm just going to subtract the 3/4 x over both sides. I know this is sloppy. And you want to put the x part first. So this would be negative 3/4 x plus y equals -5. Does that make sense if you subtract the 3/4 x over? I know I kind of struggled to write it in there nicely. And I would say this is good enough. Some books might have you multiply the negative out, like you could rewrite it as this. Like you could just flip every sign in your equation. But to me, does this really look that much better than what's above it? I don't know. I don't think it makes a difference. But based on the definition that are in these notes, and I believe that are in your textbook, I do believe it says A shouldn't be negative. But I don't know. It really doesn't bother me. But I've seen different definitions. I mean, if you're actually doing something with things in standard form, I don't really think it matters if your first coefficient's negative or not. But so I'm pretty easygoing, but I guess you could have a math teacher someday that's like, no, it needs to be positive. And I don't know, maybe it's not a bad habit to get into, but that's all standard form is. You just want to get your variables to the left side. You always put your x's first, then your y's, then your constants on the other side of the equal sign. So that's standard form for you. It's not very helpful if you're graphing. Like this is not very easy to graph. Like, I mean, you'd probably want to change it to one of the other forms. But it is nice if you're solving like systems of equations to get them in this form. So that's all I got for standard form. But it can be kind of a pain getting equations in standard form, depending on how messy they are. But so it can be a pain, but it's nice, like I said, for systems. So so these are our three forms of a line we're gonna see this year, or you should be familiar with. The first one is what we saw yesterday, slope-intercept form. You use this form when you know the slope and you know your y-intercept. Hence why we call it slope-intercept form. Point slope, same idea. This form's good to use when you know the slope and a point, or when you know 2 points. The nice thing about point slope form is you need to know the slope, but you can use any single point. So if you don't know your y-intercept, but you know a point on your line, you can easily use this form. So it's a little bit more flexible than slope-intercept form, which can be nice if you don't know your y-intercept. Standard form, as you can see, it's just the definition. Standard form is, like I said, not really nice unless maybe you're solving a system of equation. That's really the only place I can think of, at least off the top of my head, where you would want an equation in standard form. But so these are the three forms we'll be kind of dealing with. One thing I'm going to ask you to be able to do is kind of be able to change from form to form. We'll see that in our next example. So I'm going to keep moving just because we're a little rough on time. I'm sorry if people are trying to write. I'll see if I'm not going to be able to fit it up, but I will post these notes, like the key up, and I will post a video of me going through it in case I'm going a little too fast. So I do apologize. Hopefully I'm not going too fast. So All right, so example 3, we have a line goes through the points 3, 1 and 4, 2. We want to find the equations of the line in all 3 forms. So we're going to start with point slope form because it's usually the easiest one to get when you have 2 points to start with. So the first thing you need to do, no matter what, if they don't give it to you, is we need to find our slope. I guess I don't need to rewrite these points. So hopefully by now we're good enough. We can just plug it into our formula. So it would be our y's, so 2 minus 1 over 4 minus 3, or you could have these reversed. But if you're doing y2 minus y1 over x2 minus x1, it would be this. So our m, or our slope, is just going to be 1 over 1. So our slope is 1. What's happening? I don't want to be productive. All right. So recall, slope or point slope form is this: y minus y1 equals m x minus x1. So we're just going to plug it into that form. So our answer would be y, and you could use either point when you do this. I'm just going to use the first point. So it would be y minus 1 equals our slope of 1, and then x minus our value of x, which is 3. You can use either point though. You could have used the 4, 2 point. It won't change your final results. I usually just use the first point though when I plug it in. But if one of the points looks a little bit nicer, maybe you don't have as many negatives, or maybe it's smaller numbers, you might want to pick that point for some reason. All right, so we've got our slope-intercept form. The next one that's probably the easiest to go to is slope-intercept. So we'll kind of work kind of to the right and then to the top, if that makes sense. So to get it in slope-intercept form, we just need to kind of get y by itself. So we really have y minus 1. And if you had a slope that wasn't 1, you'd want to distribute. But obviously, that would just be x minus 3. But if you had like a slope of 2, you'd want to distribute that 2 or whatever it is. So then to get it in slope-intercept form, we just need to get y by itself. So just add that 1. So our slope-intercept form would just be y equals x minus 2. So then to get it into standard form, I'm just going to rewrite this slope-intercept form we just got. But remember, standard form is that ax plus by equals our constant. So we just want to move the x's over. So it would be negative x plus y equals negative 2. And for me, I think that's good. Technically, based on the definition in the notes, they say they don't want the first coefficient to be negative. So if you want, you could just multiply the whole equation by negative 1. That would get rid of it. So I guess technically our answer would be this. Positive x minus y equals positive 2. But for me, at least as a teacher, I don't know, maybe I'm like committing a math sin or something. I would take this answer as well. I think that's good enough. If you really need to get rid of that coefficient, you could deal with it. But to me, I really don't think it's a big deal because I've seen the definition defined differently. So I don't know. Any questions about this? So one thing that I am going to want you to do, like I know on your first quiz, there's going to be a question where I either give you one of the forms to start or give you 2 points, and I'm going to ask you to find each form. So one thing that is going to be important for your quiz is you're going to need to kind of know, you don't have to have it memorized by heart, but you at least need to know like these basic forms, or at least know what they look like. I mean, I'm not going to ask you what is point slope form. Can you give me like the y minus y1 equals m times x minus x1? But you do need to know it well enough to at least put your equation in that form, if that makes sense. So that's it in terms of our forms. The next big kind of concept in 2.4 is they talk about parallel and perpendicular lines. I'm going to show you how the book does it. They use point slope form, or do they use slope intercept? Oh, okay. I'll kind of go, I'll follow my notes here, but they might do it a little bit different. But if you remember how you did it in geometry, I'm guessing you probably just used slope intercept form the whole time. It kind of went like that. If you want to just do it how you did in geometry, if you remember, just whatever you're most comfortable, it doesn't bother me. But I'm going to kind of walk you through how the book does it, just so you can see. If you like this way, go for it. If you remember an old way or you have a different way to do it, doesn't bug me one bit. But parallel lines, remember, have the same slope, but they have different y-intercepts. Okay. So write the equation of the line parallel to this line through this point. So they're kind of jerks. They don't give you the slope. So you kind of need to get it in slope intercept form just to find your slope. So kind of do that quick because we're kind of a little bit on a time crunch, but you would subtract the 4x. So then you'd have 2y equals negative 4x plus 7. So then you got to divide everything by 2. Just make sure you divide every piece. So our slope intercept form would be y equals negative 2x plus 7 halves, or if you want to put 3.5, if you like decimals, go for it. So they made this problem a little bit worse because they don't give you the slope to start with. So that's why we kind of have this extra step in this first box. But now that we know our slope, looking at that formula, since it's parallel, it's going to be the same. It'd be negative 2. And we have a point. They gave us this point like in the directions, but we have a point at 4, negative 2. We're just going to put it in point slope form. So it would be y minus y1. So looking at this point, well, since it's minus negative 2, that would be plus 2 equals our slope. So negative 2 times x minus x1. So x1 is just 4, so minus 4. And that would be our answer. The next box says get it in slope intercept form, but I mean, if you got it in point slope form, why would you change it to slope intercept form? Because it's easy. We'll see. We'll look at it tomorrow, but it's really easy to graph point slope form. It's just like graphing slope intercept form. So there's not really any advantage. So this box seems like they're just kind of putting you through the ringer. I mean, you could get this in slope intercept form by just distributing, solving for y, but it seems like they're kind of just making you do work to do it. I don't see any reason why you'd want to do that. Unless you just really like slope intercept form. Okay, let's just look at a quick example with perpendicular lines, and this will probably be it. I probably won't be able to do these last 2 examples, but I'll put them up on like in the notes if you want to look at them. But remember, perpendicular lines have opposite, reciprocal. Crap, how do you spell reciprocal? I think it's R-O-C-A-L, I think. I always usually flip the O and the A. I think the O comes first and then the A. But they have opposite reciprocal slopes. So very same idea. They're nice in this problem. They give it to us in slope intercept form, so it's easy to find our slope. So the old slope was 2/3. What's the opposite reciprocal of 2/3? You guys remember how to find an opposite reciprocal slope? Remember, you just flip your fraction. So good, Brooklyn and Layla. So you guys got it. I'm sure other people too, but you flip it. So the 3 goes on top, the 2 goes on the bottom, and then you flip the sign. Since it's positive, it turns negative. So we're just going to write our equation in point slope form. So that, remember, that's, I guess I should have written it down on the last one, but because you're probably not, I don't know how much you've done or if you've ever dealt with point slope. That's the form. So we're just going to plug in what we know. So it's going to be y minus and we're going to use this point here. So y minus 6 equals our new slope, so -3/2, and then times the quantity of x minus our x value from that point would be 0. So I guess you could just put x there, but I'll just keep it in the form because most of the time you probably will have something. So that would be our answer. I'm not going to worry about getting it in slope-intercept form because this, if you're actually graphing this, this is just as easy to graph as slope-intercept form. So I don't really see a huge advantage, but I mean, if you really hate point slope form and you like slope-intercept form, you could just distribute your -3/2 and then add the 6 over. I mean, it wouldn't be hard. This would be your answer if you really wanted to do it. Like I said, I just honestly don't see a lot of advantage unless, let me just double check to these questions. I guess since it says write it in slope-intercept form, I guess I should have done that. If it asks for a specific form, obviously give your answer in that form. But I'm pretty sure when I ask you to like find an equation on your quiz, I just say find the equation. So if you want to get it in point slope form, go for it. If you want to get it in slope intercept form, go for it. So I'm usually pretty easygoing because at least in my opinion, I don't know, maybe there's different mathematicians with other opinions than me, but I really, point slope form, slope intercept form, they're both very versatile. I mean, I don't really see an advantage over one than the other. Some teachers really, I know like in your freshman year probably dealt mostly with slope intercept form, like y equals mx plus b, so, but some teachers really try and encourage point slope form. But personally, that's all I have to say. So let me stop